So today I've been playing around with a new to me, assembler package called Turbo Macro Pro 1.2. This seems to be a very popular assembler package used by a lot of retro programmers today that are programming on real hardware, or in my case, in virtualized hardware. So I finally took the plunge and spent about a day playing around with it, and I think I've got a pretty good grip on how to use it. So we're going to start with just a Commodore 64 and a disk drive, and then we have one disk which has the software on it, and then a blank disk which is going to have our project on it. So let's get started. Let's first take a look at what's on the disk. So as you can see, this disk has a lot of software on it and a lot of little commentary kind of thrown in between it with websites and lines and things like that. We're only going to worry about two programs on this disk. The one at the top that says TMP v1.2, that's the package that works on this kind of computer, just a Commodore 64 with nothing special on it. And then another program called TMP Prefs. So we're going to start, believe it or not, with TMP Prefs. It's a basic program, so we're just going to load it, comma 8. And we're going to run it. What this program does is it lets us configure colors and hotkeys and other such things for the assembler. It actually does one other bonus thing, which is what I'm really using this for. But since we're in here, we might as well customize it just a tiny bit for us. It uses an editor very similar to Turbo Macro Pro to configure itself. Well, the first we need to do is load in a copy of Turbo Macro Pro that we're going to modify. So you press the back arrow, which for now I'm going to call Command, and L to load. It's going to ask me for a file name. We're actually going to load in the Turbo Macro Pro for the stock 64. And that is TMP space and an asterisk. And again, that's the file there that we're going to be pulling in. Now this just takes a tiny bit shy of forever to load. It's going to ask us if we want to overwrite press from loaded. Sure. Not 100% sure what that does, but we'll do that. And we're just going to set the background color to make our copy unique. So we're going to do Command C. Oops. It's asking us which color. If you look at the website, you can see here they show you a list of the types of colors that we want to work with. 0 is the border, so we're just going to change that. So we're going to press 0 and ask you for a value. You're going to press the control keys like you do on a Commodore to pick the color you want. So I'll press like Control 5, for example, and then it'll make it purple. Not sure if purple is what I want to go with. So let's try again. Ooh, yeah, I think I like that blue. And with this, we're going to save a new copy. Before we do that, we want to put in our blank disk. Okay, with our blank disk, we can use Command asterisk to see what's on that to get a directory. Here you can see it's blank. And now we're going to save it with Command S. And we're going to call it TMP. And again, this takes just a little bit short of forever to save it. Cool, we'll do a directory again. And now on our blank disk, we have our own personalized copy of Turbo Macro Pro with a blue background. And then from here, we'll get started by working on our first project. All right, to launch it, you type sys32768. So let's just throw together some quick code. All right, so right off the bat, this is a full screen editor, which is awesome. I can just move around and just type code. You can see at the bottom it has our X, which is the column we're in, and then it has L or line or the row that we're in. So we can just easily move around. This is just too cool. if you take a look at where it says IN colon, that is the two insert modes that are available. There is line mode, so if I press enter, it'll push things down, right? And then there's character, where I can just move things over, right? You'll notice when I push down, it automatically reformatted the code to make it look nicer. You can delete lines with Command and then a delete key. So I can pull those back up. If I press insert by itself, it turns character insert off, so now it deletes stuff, okay? And then if I press Command, then insert, oops, it turns off insert mode when I press enter. So I'm gonna put the defaults back because I actually kind of like that. The number sign you see at the bottom with the 8 next to it is the current drive that you're using for all the commands. So if you press Command D, you could cycle through the 2 disk drives, at least that I have on my virtual machine, all the way up to I think 4 disk drives. So if you have an 8, 9, 10, 11, it would just cycle through them. We're just going to focus on working with drive 8. So, and then the next part, where it says B:$7 FCB, this is your source code and how much RAM it's using. Now you'll notice as I type things in, the number goes down, right? Which seems kind of weird. So let's delete this. So we're going to talk about memory here for just a moment. As you can see from this picture, Turbo Macro Pro eats RAM for breakfast, lunch, and dinner. So basically this is kind of an exaggerated memory map of the Commodore 64. So what happens is it sits at 8,000 hex and eats everything forward to the end of it. Obviously, there's things like ROM and stuff like that. Like I said, this is an exaggerated map, but basically you can't use anything forward. Be really careful what you use from 8,000 and downward. That's where the source code. The arrow implies that as you type more stuff in, as you just saw, it moves further to the left or lower into memory for the source file you have in the editor. So you're kind of left with a little bit of space between slightly past where basic starts at 1,000 and forward for our assembled code while we're using the editor to code, assemble, run, you know, that kind of workflow. So that's why the program starts at 1,000 hex. All right, well, now that we've talked about that, let's assemble the code and see how it works. To assemble, you're going to press Command and 3. And this is going to assemble into that memory location. You can see here it says a few bytes long from address 1000 to 1000F. We have the option to press a key to go back to the editor or S to run it. We're going to press S. We're going to be a little daring. You'll notice that it blinked really fast and now we're left back at basic. Believe it or not, our code did run. We just didn't get a chance to see anything. So let's get back into the editor, and you do that by sys32768. And now we're back where we left off. So let's add some code to wait for a key press. So this code's pretty straightforward. We've created a label for cold wait for key. We define another label to demonstrate where our loop is. We're gonna make calls to the kernel to see if a key was pressed. If it's 0, nothing was pressed. We go back into the loop until something's pressed, and then we return from subroutine. Very straightforward. So let's give this a run. And now we press S to start. Now this time, you can see the border color change. It's waiting for a key, we press it, and now we're back in basic. And now we're back in our editor. So let's save this. So you use Command S to save, and we're gonna call it Hello World. Okay, and if we do Command asterisk, we can see that our customized version Turbo Macro Pro is there, and our Hello World program is there. It's not really a program. The source code is stored in their own binary format. Although things get a little different when we work with macros and subroutines, which we'll get to in just a moment, our program is saved. Okay, so let's try cleaning this code up a little bit. We're going to take this wait for key subroutine and turn it into a macro. So at the end, it'll just be 2 lines of code instead of 4. 4 being the JSR, the loop itself, the branch, and the RTS. So here's how we're going to do it. First, we're going to turn this into a macro, and we do that by just typing in .macro after the wait for key label. And then down here, you tell it that it's the end of the macro. Now I can purposely type this in wrong because this is a really cool feature. It turns it yellow because it knows it's not a real pseudo opcode. It's actually endm. I like that. It's a very simple syntax highlight checking. It's really nice. All right, so now we've got our macro defined. We're not going to need this, so we can get rid of this. We're going to get rid of this RTS line, so it's command delete. Now it's gone. And then instead of JSRing it, you put a hashtag. The hashtag expands a macro. So those 2 lines of code, the JSR and PEQ, will just appear right where the hashtag is. Now we're almost there. If I try to assemble this, this should fail. So I'm going to do command 3, and it fails because it doesn't know what wait for key is. Macros need to be defined before they're used. Well, I don't really want to put this at the top of my program. It's kind of ugly. So we're going to move it to its own file. So first we're going to mark the block of text, and you do command MS to start to mark the beginning of the text. We come down here, and then we do command ME, so it's command mark end, and now I've highlighted a block of text. Now, of course, in a modern IDE, we would just use a shift key to move the arrows around, but this works pretty well, can't complain. So now we have the text marked, we've got it highlighted. We want to move it to a new file, and you do that with a block command. So you do command block, which is B, and you've got 4 options. You have move, copy, which is basically moving it around the same file, kill, which just deletes it, or in our case, W, which writes it to a file. So we're going to do W. We are going to write it to a file called waitforkey.m, where .m is macro. The .m is just a naming convention I just made up today. So this will be a nice way to let us know, looking at a directory, which files contain macros. Okay. And to verify that it's there, because we always want to make sure that it's there before we delete it, we can do command asterisk. And there we see our macro file on disk. Notice, however, it's a sequential file this time. The macros and subroutines get written to sequential files. So anything included into our project or into our program will be a sequential file. Speaking of including it, let's include it. So let's go up here. Actually, let's do it over here. And we're going to do .include, and then we called it wait for key.m. Now this block of text we no longer need, so we can do command B and K, and we're going to say yep. So let's give this an assemble. You'll see there that it brought the file in. Let's run it with S. As you can see, it still works. And then let's get back into the editor. Let's take the remaining block of codes here that deals with setting the border color and the screen color and the cursor color and move that into a macro also. But this will be a slightly more advanced macro that it's going to take parameters where we can pass in those colors. So let's first create the expand macro call so we can kind of see how we want it to work. So we're going to do a hashtag set colors, and we want to pass in the values in those LDA statements. So we're going to pass in 02, 00, and 01. So it's red, black, and white. And you separate them with commas. Now we want to move this. So we're going to do our mark set, mark end. We're going to move the block of code here. Okay. And then we're going to create a macro called set colors. So we're going to create a label set colors. It's a macro. This will be the end of it here. And now we want to put placeholder values here. And the way that works is you use the English pound and a 1. That's going to represent the first value here. This is the first one, the second one, the third one. So this first one, which we already did. Here's the second one. Here's the third one. And that's it. So let's move this to its own file. We'll mark this again. block right, and we're going to do a set colors.m. Okay, we're going to kill this block of code. And then we're going to include it up here. Okay, let's try this out. See our 2 macros included. We can run it, and everything still works. Okay, let's explore working with text. Let's create a pointer to some text. So here's a new pseudo opcode .null. This works like .byte does in other assemblers, where you can insert characters straight into memory. Well, the one key difference is that it puts a 0 at the end for us. So this is a null terminated string, which is great because we can pass this to lots of different routines that we're going to write to manipulate strings. Another neat thing you can do is you can, using Command A, you can enter into like the quote mode in BASIC, where you can insert screen control commands. So we're going to insert a clear and set color white here. So Command A, clear, Control 2, and Command. And now we've inserted those characters. It looks a little different than BASIC. I think BASIC has a heart and maybe a capital E. I can't quite remember. But it's there. Now let's write a subroutine print to print this to the screen using the kernel. I love how as you're keying the code in and you're moving the cursor down, it just kind of moves everything into the proper columns for you. This makes programming, in my opinion, really, really efficient. And as I was just saying those words out loud, I realized I forgot to increment X there. Okay, and then we just need to add a call up here to. All right, let's assemble this. And let's give it a start. And voila, that works. It's probably time we should probably save our copy of our code here. We wouldn't want to lose it. We've done a lot of work so far. So this current subroutine does a great job of printing hello world. But we want to make this routine a bit more generic, where we can pass it a pointer to any text so we can reuse it many times throughout our code. So let's first kind of document what our goals are for this routine. So we want this to be a print JSR accumulator to contain the low byte of the pointer. And then we want the X register to have the high byte of the pointer. Okay, so once this JSR gets called, we need to store high byte and a low byte into page 0 so we can use indirects by Y to get to it. It's really not as complicated as it sounds. So we're going to store the accumulator in FB. There's a little tiny block of 0 page that's pretty safe to use. In FB and FC, we can use those to store pointers. So we'll store the accumulator in FB, and we'll store X in FC, so they're next to each other. So together that reforms really the address of what we're going to print. All right, we're going to set our index, our Y index to 0, because that's what's going to go through each character to find it. Okay, and then we're going to kind of get rid of this line. We no longer need that. So looping through now, instead of looping through the pointer to HW text, right, we do this. So what this tells the CPU is look at the memory address stored in 0 page FB, and it'll also look at FC, and it puts them together and it makes an address, and then add Y. Well, Y starts at 0, so not a big problem. All right. If you load in a 0, we're done. That's where it jumps down to print we're done. Otherwise, call the kernel to print it out. Instead of increasing X, we want to increase Y. And then we're going to jump back to the loop and then do it with the next address. So really pretty straightforward, believe it or not. Now, how do we call this? Well, here we were just calling print before. So we need to load into the accumulator the low byte and use a less than sign for that. And you pass in the HWTXT pointer. And then we load the high byte of the HWT text label. I said pointer previously, I meant to say label. And then we call JS for print, and that should do it. So let's make sure this works. And it still works. So even though it looks like it's more work to get the same thing done, the nice thing about this is anytime we have text we want to print, we can call this JSR routine to do it. So while this routine works, there's a potential landmine sitting here, and it's this loop label, and actually the PRT done label as well. And the problem is these might be used elsewhere in your code. It's a pretty common name. So one thing you can do in TurboMacro Pro is you can create what's called a block of code, and you put dot block here, okay? And then at the end of our routine, or end of the block, if you will, we put .bend. Now we need to expose this to the entire program so other code can call us. But what block does is it says all of the labels in this section of code are private to this block. So I can reuse loop in different places and it won't conflict with each other. It's very important to put that in when you're creating subroutines. So now that we have that there, let's move this to its own file to make our code more readable. So we're going to do our usual mark start and end. And we're going to write it to a file called print.s. And for me, S means subroutine. I think print.s might be used as .source for other developers, but in our naming convention we created just today, it's going to stand for subroutine. We'll kill off that block of text, and now we need to include it. Now, you might be thinking to include it here, but keep in mind, it works like macros. Macros aren't actually expanded until you call them with hashtag. When we include .s files, that code is going to appear right here before all of our other stuff. So we actually want to include that at the end. All right, let's check this out. Okay, we can press start, and everything still works. So now we've got quite a bit of code in our program, and yet our program still fits on one screen because we're saving our subroutines and macros to separate files, and our code is much more readable because of this. Okay, let's save this real fast. So I just want to spend a moment and talk about the different types of files that are in a project. So we have hello world, our PRG, and that's our source file. And you use Command L and Command S to load and save different source files. Anything you include, however, is created as a sequential file. The commands you use to read and write those are W to write and E, I guess, to get. I'm not quite sure what E stands for. So let's try to grab one. Let's pull in set colors.m. You can see when I use the E command, it brought the text right into the middle of the source. This is actually really useful for pulling in code snippets into your code, but we actually just want to edit that file. So to do that, you want to clear the editor with Command C. It's really cold start, but I like to think of it as clear. And then we can use E again to get that file. And then we can make changes to it. And we can use Command W to write it back out again. Let's bring back the source file. So another thing I want to talk about is where we compile. As we mentioned earlier in the video, there's not a whole lot of places to compile this code. I don't really want my code to be at 1,000. Let's say I want it to be at 8,000. Okay, and 8,000 of course is 32,768. The problem is if I assemble that with Command 3, it's going to overwrite the assembler and just create problems. So instead what we can do is we can assemble to disk, and we do Command 5 for that. And instead of writing it to memory, it's going to write it out to a file. So let's put it out to hello 8000. It'll assemble as normal, but instead of giving us a chance to run it and having it sit in memory, it just writes it straight to a file. And you can see it there as hello $8000. Let's test it and make sure it works. And of course it works. So there's another way we can save this object code to disk. We can save it in such a way that it looks like a basic program. This will make it really easy for users to load and run a program without knowing much about it. They can load it comma 8, comma 1, or comma 8, and then just type run. So here's how you do that. First, you want to configure your program to compile to 801. That is the start of basic. And then we want to include some bytes, which is like a descriptor of a one-line basic program. And here's what it looks like. Cool, so what does all this do? Well, in a basic program, the very first 2 bytes is the memory address of the next line of code after the first line of code. And you'll notice that it's in little endian order and it's 080C. Well, if this is 1, 2, 3, 4, 5, 6, 7, 8, 9A, there's a B, that's the null terminator, and C. So it's a pointer to these 2 records. The second line being null, 2 zeros, that's the end of program. So this describes a one-line program. This is the actual line. This is in little endian order, a 16-bit value of the number 10, line 10. 9E is the basic token for the sys command. This is an actual space, as if someone pressed a space. And then this is the numbers, just as a string, 2062 with a null terminator. And that's it. And because 2062, if I use my handy calculator, you can see 2062 is 80E. Well, if this is C, this is D, and then the next thing is my program, which is E. So we're basically syssing out of basic after the end of the program, right to our program. Kind of a neat trick. Now, with that said, this is kind of cool, but it's kind of in the middle of our program. So let's move this to an external file to make our code more readable. So we're going to do Command MS for mark start, Command ME for mark end, and we're going to do Command BW to write this out. We're going to call basic.s. Okay, we're going to kill this block, and then we're just going to include it. Excellent. So this is our program with a basic loader. Let's save it and try it out. Now we're going to assemble to disk. We're just going to call it hello. All right, let's see how well this works. So I can list it, and you can see it has sys2062. And if I run it, our program runs. Let's try with comma 8, comma 1 this time. There it is. And we can run it. Pretty neat. So ultimately, what did I think of Turbo Macro Pro? I really, really loved it. This is a great assembler. On the Pros, it's easy to use. It took me about 6 to 8 hours to kind of get in and really get the hang of it. It's customizable, which is really nice. It's very quick and easy to navigate between files in your project. I can get it directly on a disk. I can look at a file. I can edit a file, and it's really, really quick. It has error highlighting, which is really nice. So if you type in mnemonic wrong, it'll highlight it yellow, so it's really easy to spot and correct. I noticed as you type, it kind of auto-formats the code. So as you're brain dumping code onto the screen, it's reformatting a few, which is really, really nice. The multi-drive support's pretty good. I don't think you really need it because you can just create a blank project disk, but it is really nice that you can switch between drives with just a quick command. Just a couple of small cons. One was getting code to a machine language monitor is a bit of a chore. Because it eats up all the RAM, you can't really easily have a monitor, whether in cartridge form or really any form, sitting on standby. I'm sure there's tricks with like Super Snapshot and things like that to freeze and get to a monitor. But if you're just running on a stock 64 and maybe you have a Hessmon cartridge or a Salter monitor, it's a tiny bit of a chore. It's not the end of the world. The Pros far outweigh the minor pain of dealing with that, but it is a minor con. And the documentation wasn't the best. It was complete and it was thorough, but I had to really dig through to figure it out. In fact, what I ended up doing was kind of taking their documentation and kind of rewriting it in Word and breaking it up, which actually was a good way to learn it also. So I kind of broke the keyboard commands into groups, so it was very easy to just go to like the assembling run section or disk and file management commands and just kind of see them all, as opposed to seeing just one giant list like on the website. There's things I haven't even touched yet. I haven't even touched the REU support, which sounds super exciting. I definitely see myself using this assembler for writing code. The C64, I think this will be the assembler I use to start learning how to write games and maybe get my first game written. Of course, it'll be something incredibly simple, but I'm very excited to move forward with my journey in learning how to write C64 software. I hope you enjoyed this video. It was really, really fun to make, especially this one. I had a really good time learning this assembler. And thanks for listening. Take care.